So myself, I'm Marcin Detyniecki. I work for a large insurer, which is AXA or AXA, and I run a research team. And the fact about me is that I started artificial intelligence a long time ago in the middle of the winter. And I guess I'm a little bit feel responsible of the mess it's producing in the society. And this is why my research is now focusing a lot on making these things more better, either transparent or managing biases and so on. And so I will talk today about biases and under the title, Can AI Design a Fairer Future? And so the fun thing is, you have probably heard about this, is that there is a contrast between human and machines, and we tend to believe that humans are much better and much more fair. And there is this example that was a compass. It's not really AI, but it was giving kind of a high-risk scores to people of color and was giving a lower score for people who were white. And there was a high debate. I'm not going to enter into this. I just wanted to make just a second ask you that this is shocking. But what is shocking is actually the fact that you all are thinking this guy, this black, this white person is a very bad person. You don't know anything about it. It's just because it looks bad. So maybe machines are better actually than humans, to be fair, because they're neutral, right? But there's something that bothers us with machines, as everybody's talking about machines. So what is wrong with machine? And the problem with machine is that, or let's say with AI, or even more specifically with machine learning, is that actually these machines tend to learn what they have seen in the past. So a typical example of this is historically engineers are males, and if you introduce a variable in the data set, then what happens is that you will probably reproduce this. And then when you will select a good candidate, you will say it should be a male. Say, okay, then you say, well, that's fine. So we build this complex model with this, and that's fine. So how we can deal with it? An idea is to say, well, no good. Don't tell the machine anything about the gender, right? This is not good, so you're going to take gender out of it. You're going to say the machine has no idea. But if you look at the CV, you will find very interesting things, such as, for example, hobbies. And for example, somebody doing ballet, or maybe something about the color of their car if you're an insurer, the size of the car. And with these little variables, actually the machine will reconstruct internally, and it will be not even explicit, will reconstruct this variable, and then will predict again, because your data set was biased, will reproduce this again. So the thing is, the problem is very indeed. So can actually machines, can AI machine design a better future when it's this like this? And this is even worse by the fact that the machines today are black boxes. I mean, if you think about large language models, they're huge, they're very big, and there's so much parameters in it that you can do. So could we do this? And this is something that we try to do. So for this little exercise, what I designed here is I have a training set. So I'm going to try to learn how a 0 looks like, try to have a classifier who's going to, when I show an image, if it's a 0, will tell me a 0, if it's a 4, it will tell me a 4, and so on and so forth. But here, on purpose, I put a little bias in it, which is the color. So actually, all my 0s are red, and all my 2s are yellow, and all my 5 are purple, and a little bit of noise of it. So for the machine, it's so much easier to learn the bias, so much easier to learn that the color is the number than to learn actually the shape, which is much more complicated. We have much more variation here. Okay, so it's very close of a kind of a thing that you could transpolate to selecting people in a CV. So the thing is, we did a program which not only learns actually to predict the features, so meaning the number, but at the same time tries to fight against the reconstructing these hidden variables, okay? So we have a new architecture, which is called adversarial learning. So we have something that will reward if we correctly predict whatever we wanted to predict. For example, we predict a 0, we predict a 2, and at the same time, we will punish actually the gender, we will punish the algorithm by showing them and telling them, okay, actually you predicted using use the color somehow, okay? So if you want to look, and because we're at MIT, I brought a little bit, I opened the hood. So here you have something that tries to reconstruct for your sensitive variable, so this being the color or the race or the gender. We have an embedding here, Z, and we try to reconstruct here with these two neural nets. We try to reconstruct, and we try to make sure that there is no information in Z about S and X being thing. And then when you use the algorithm, you will use X will predict Z, which will predict Y, okay? And then you will have guarantees that actually your system is completely fair. Okay, it's absolutely completely fair as long as you define what actually fairness means, which is another problem that we have. So this is actually how the thing works. And then a little test to check if it really works. So what we did is very simple. We train in this data set, and then we do something very simple. In the test set, actually, we change the colors. So it's very simple. We just put random colors. And then you see, if you try to do this without having any, so this is lambda from the previous problem. And then you see, if you try predict, you are at 0.47. And then if you do what I just described, you are at 73. So actually, you're able to predict without taking into account the color, and you are predicting quite well, which is something very, very interesting. So this brings me to a little bit more higher question, which is actually seems to be a little mathematical exercise, but at the same time, something that has a strong impact in society. And the impact is that in order to do this thing, actually you need the variable S. So the variable, you need to know the gender. Actually, you need to know the race. And so you need to have the information of who is being discriminated. And this is very strong as an information because actually if you want to, for example, protect people, you need to know who are the poor or vulnerable people. And if you're an insurer, this means that you should give this information to the insurer to make sure that this insurer is going to be. So do you trust your insurer for that? That's the only question, but this is the only way. And this is really profound because if you think about justice and you look at the justice is blind. We don't want the justice to look at you because of your color or because of your ethnicity or whatever. But in reality, if we want to be really, really fair and we want to be non-biased, actually we need to have open eyes and take care of it. So I think as a conclusion, yes, I believe AI can help us design a better future, but then we will need to trust the humans. Thank you for your attention.